Thanks everyone for joining this morning and taking time out of your Wednesday to learn with us, to learn about building intelligent AI apps with Redis and Azure. We have two fantastic subject matter experts here joining us today, Catherine Wang, Principal Product Manager for Azure Cache from Microsoft, and Justin Cechmanek, Senior Applied AI Engineer from Redis. If we want to pop over to the agenda slide, please, we can cover what we're going through today. So we've got some really good topics on the board, large language models, semantic caching, conversational AI for chatbots, retrieval, augmented generation, GenAI, and OpenAI, and we'll even be going through a live demo. So really excited to get through some of this content with you all today. And if we can pop to the next slide, please. Perfect. We will be recording the session and sharing the on-demand version with you all post-event so that you can revisit the content at any time. But if you do have questions, please feel free to drop them in the chat. We will do our best to get to them at the end of the session or follow up afterwards with a subject matter expert who can chat with you further and answer any additional questions that you have about the content. This QR code that you see on the screen here actually takes you to a brief Google survey. It takes just a couple minutes, but we'd love to hear your feedback throughout the session, how you like the session, anything else that you want to share with us. You can share feedback in that survey as well. And as a thank you, we will actually be sending you a $5 gift card once you've completed the survey. So go ahead and scan that QR code. We'll flash it up again at the end of the session, and I'll also drop the link in the chat. And again, any questions, please drop them in the chat. With that, I'll go ahead and pass it to you, Catherine.
Hello, everyone. So a large language model is a popular term mentioned everywhere nowadays, but exactly what it is? Well, it's a computation model for interpreting asks and generating responses based on natural languages. It can perform tasks like Q&A chat agent or summarization and classification scenarios. At a high level, there are some key concepts associated with large language models. Vector embeddings. These are for transforming our natural language input into a matrix of floating point numbers for large language models to understand. Feature parameters. So these are gigantic matrix for the large language model to make sense of each word in a sentence, as well as its context and correlation with other words. For example, in the diagram, in the question, where is the capital of France? The large language model needs to know where indicates a question about the location. Capital and France are both nouns, while capital is related to France, and so on. All these are stored in the format of some numbers in a matrix. So apparently, the more matrix parameters the large language model can process, the smarter it is. GPT-3 has 1.7 billion parameters, and GPT-4 achieved 1.7 trillion parameters. So just to provide an idea of the amazing scale we are working with. Context window. There's a limit of how much information LLM can process in one round, which would require your application to search concisely, providing the zipped format for the additional content when sending an ask to it. And we will explain later, like that's where all the vector similarity search and the vector embeddings would help. Prompt. Like any of us human beings, large language models are trained in certain ways and could understand some styles of languages better than others. So there is a whole guidance on prompt engineering for getting better answers or responses from large language models, such as GPT. Stitching together these concepts, how large language model works is that your input will firstly be transformed into vector embeddings. Then it will go through many iterations where in each step, it will try to understand the words and the sentence, make meaning out of it, as well as predicting what are the possible next words? So each step is done using the matrix transformation process. And in the end, the large language model will give an answer that it predicts to be the most likely next words following your input. GPT-3 goes through as many as 96 iterations to ensure the answers generated are meaningful and relevant. Okay, so this is a large language model. How do we integrate it into your application? If we go to the next slide, please. So if you happen to host your application in Azure, we host large language models like GPT. It's fully managed and hosted just like any other services in Azure. These services would enable scenarios like semantic search and queries on top of the data that's specific to your enterprise or useful to your enterprise from the public internet. Azure provides built-in trust and transparency with integrated system safety and empowers responsible AI with built-in tools and process. So you'll see the screenshot. This is an example of the Azure OpenAI GPT model playground in Azure. You can see there are controls and parameters you can tune. So after you deploy your model, you can configure how the model responds to questions like the randomness, or if there's a specific style you wanted to answer the questions, making sure it's fully customized and ready for your application. Try it out with your Azure subscription today. So now, after we explain the large language model and the Azure offering for it, how would Redis plug into everything? Yeah, so Redis works very well with large language model and Azure OpenAI services for accelerating your intelligent application. In case you are new, Redis is a distributed in-memory key value store. Redis Enterprise provides many more benefits, including modules such as Redis Search. Redis plays a key role in the Retrieval augmented generative AI applications. So for example, if you have some data that's specific to your enterprise, such as the HR information, large language models would not know about it. And it will be very hard to train it just for your own enterprise. So in that case, Redis can be used as an external knowledge store. So Justin will go through more details with the sample application later to show you. But a few quick scenarios. So in addition to the external knowledge store, Semantic Cache saves response from questions that's asked in different ways, but really similar in meaning. Using Redis to save the answers to these questions would increase the performance and save cost from calling into the large language models. User session and chat history. So large language models are stateless, meaning every time you ask a question, by default, it would not remember it next time you ask it again. But there could be useful information you wanted to remember throughout a chat session. Redis is historically the session state store and can be extended into chat history. Performance acceleration. If your intelligent app needs leaderboard, distributed caching, etc., like the classic Redis caching scenarios, those would still work with intelligent applications, and Redis is a very good choice for your multi-purpose data store when building intelligent apps. So let's just explain a little bit more on how this could work in Azure. So we offer Redis Enterprise as a jointly hosted service in Azure. This means it's not like you are using Azure, but with any other like a third-party partner product. Redis Enterprise is treated as a first-party hosted service with seamless Azure integrations and well-polished experience, while you still get all the benefits from the Redis Enterprise software. So in the case of intelligent applications, you can consider using Redis Enterprise in Azure as your vector data store. It provides rich search capabilities, accelerated performance, and the unparalleled 5.9 SLA with active geo-replication. The screenshot shows how the resource provisioning page looks like in Azure portal. So if you are interested, please check it out. We talked about Redis in RAG AI. So this is an overview for how Redis would be used as a vector database for external knowledge in the RAG AI scenario. Firstly, you see the retrievals type. This means after your or a user's question gets translated into the vector embeddings, it will then be searched against your external knowledge store. This is where like Redis would be preloaded with all the vector embeddings that's transformed from hundreds or thousands of PDF files, text blobs, and so on. So the retrieval stage would search in the Redis knowledge store to find the information that's relevant to the question a user asks. And then the search result will be attached to the original question prompt. This is what we call augment. So attaching more relevant context information to the user's question after we search into Redis. Then the augmented prompt will be sent to a large language model, such as GPT, for chat completion. The answer generation part is what we call like generate. So this whole process like retrieval, augment, generate. This is a pattern used a lot in today's chatbot intelligent application scenario. And we'll just go through another very popular and useful scenario, semantic caching. If many users ask the same questions, but in slightly different ways, there's really no point to call large language model each time to generate the same answer. So this is where semantic caching can help. You can save the questions from users as a vector embedding as the key, and the answer to the questions to be the values. Every time a new question got asked, we can go through the vector similarity search to see if there's any similar questions asked earlier, and if so, we reuse the answer. If not, we then call into GPT to generate a new answer and then save it back in Redis semantic cache for later use. Using semantic cache in your application will improve the consistency and improving performance, reducing cost calling into large language models. So brings a lot of benefits. So hope this provide a good overview on the concepts. Justin will show you more details with an amazing demo to further explain this.
All right. Thank you very much, Catherine, for that excellent overview of all things large language models, RAG systems, and semantic caching. So let's talk a bit about, why we care so much about building and deploying RAG on top of large language models. LLMs are great, but they still kind of fall short in certain things. As mentioned before, they have no knowledge of anything beyond their training data. So you ask them anything about recent events, for example, who is a gold medal champion in any Olympic event that happened last week or the week before. Any model that's trained prior to July of this year won't be able to answer that question. You could retrain it, but then of course you'd have to retrain on a nearly daily basis to keep up with current events, which is at best impractical, at worst impossible. They're also very expensive. When they say large and large language models, they're not joking. Like, as Cantor mentioned, GPT models are in the billions, now trillions of parameters. That means they're slow to respond for any typical application. They're very costly if you use an external API, and they're very costly if you want to run your own hardware and deploy your own models on internal hardware or cloud compute. Anything we can do to save costs on these large applications would be beneficial. And lastly, again, they're stateless. For every single prompt you send them, they have no knowledge of what you asked them 10 seconds before. People say goldfish have memories of 30 seconds. LMs have less memory than that. So all these things are components that we can actually build out and enhance by using tools such as Redis and vector databases to be able to, shore up these shortcomings. So what I'd love to switch to now is actually a live demo, which is always risky, to see what a RAG application actually looks like. So what we're going to show you is how to chat with a PDF file of your choice. This demo code is fully available. It's hosted under Redis developer / Redis rag workbench. Feel free to play around with this. I encourage everyone to go ahead and clone this and play around with your own PDFs. It'll walk you through exactly how to do it. But what this demo is going to showcase is we're going to be able to upload any PDF of our choice. And following the architecture diagrams shown earlier, we're going to take that document, break it down into several different chunks, and then embed each of those chunks into a vector data store. We're going to do that embedding through Azure OpenAI API calls. And then we're going to host this in our case, a local Redis vector database, just running on my local laptop, though of course it could be any Redis database you choose to spin up. Then we're going to ask any question we want of our document. That prompt will go through the same embedding to be able to check and find any semantically similar chunks in our vector database and append that to the prompt that then gets sent once again to the Azure OpenAI GPT LLM. Then we'll get the response and we'll be able to see exactly what that looks like. So let's go ahead and run this. So right now, this is what the terminal, the GUI will look like. I just had this running locally. I'll be able to upload any PDF that we want. And now in my case, a big part of my job is trying to understand what is happening in the world of AI and all the recent developments that are going on with it. It's a fast growing field. It's hard to keep up with. I don't think anyone can read all the papers and read all the reviews and blog posts that are coming out with it. Luckily, Stanford every year publishes a summary of the biggest updates that are happening in the world of AI, which is great because it saves us time. The downside is even that summary is 500 pages long. So let's go ahead and upload their 2024 report, which is published, I believe, July of this year. So GPT models will not have access to any of this data. So right now what we're doing is we're just going through and chunking that PDF document into various different components. In this case, we're choosing a chunk size of about 500 characters. This is configurable through the app. Feel free to play around with this for your own application needs. And you can see it's just being loaded into a vector database. And we're nearly done, so we'll give it a second. All right, so in about 30 seconds, we were able to process this entire PDF into a vector data store. And thankfully, this only has to happen once, and now it's in there for as long as we choose to keep it. And now we can ask any questions of this PDF that we care about. So let's go ahead and see what we can learn about the latest advances in AI from this publication that GPT model wouldn't otherwise know. So let's ask it, what are the main areas of businesses companies adopting? Looks like the main areas, according to this PDF, where businesses and companies are adopting generative AI are in marketing and sales at about 14%, product and service development at 13%, and service operations at 10%. So already we're getting some new information that otherwise you wouldn't be able to know. And luckily, this RAG workbench shows a lot of different components. In this case, we're actually getting a breakdown of some of the things that our system is doing. So in this case, it took our LLM about 1 second to respond. It was 379.99 tokens per second. So that gets a measure of how quickly it is able to respond to these things with about 400 tokens total. And this gives you a rough cost breakdown of luckily less than a penny, but you can imagine scaling this up to many users or many queries. This can get expensive after a while. The RAGIS metric is actually an internal way to evaluate the effectiveness of RAGIS tools. We'll ignore that for now, but feel free to tune back in for a future component or talk to us afterwards to understand more about what RAGIS is. But we can continue to ask anything we want of this PDF. So let's see, are companies investing financially in AI? It looks like they're investing quite a bit. Companies are investing significantly in GenAI, with funding for AI applications surging to 25.2 billion in 2023. This amount is 9 times the investment in 2022 or 30 times the investment in 2019. So clearly it's growing pretty quickly. And once again, all this is information that you're able to extract from your local document that otherwise GPT or any other model wouldn't be available to. Since this is basically doing my job for me, let's continue and see if it can save me more time. What are the biggest opportunities for vector databases in AI? I don't have enough information to provide a specific answer about the biggest opportunities for vector databases in AI. Darn, I was hoping this would make all my work too easy. But that's okay. Clearly, you can see that these systems are able to answer some questions if the information is able in your PDF. And if it's not, well, that's all right. That's why this is a demo and not a live production app.
I like the fact that it just tells you it doesn't know instead of like hallucinating and give you random info.
And that's actually an excellent point. Another thing that we didn't mention, so thank you for bringing that up. One of the biggest benefits of using RAG components as opposed to just raw LLM calls is they've been shown to reduce hallucinations. So by giving it, verifiable information, in this case, your own documentation, you can trust to a much greater degree what the output is. It's not just going to generate and hallucinate random stuff. It can ground its responses in factual data that you're providing it. So once again, this demo is live and available for anyone to play around with. I encourage everyone to check it out. Going back to our deck, let's talk about what was happening inside there. So once again, that whole flow is the standard RAG flow. Uploading some document or documents, breaking it up into chunks and loading into a vector database, then doing the retrieval to augment any future prompts. So what does that actually look like in terms of code? Now, this is a highly simplified component, but I really want to show that this is literally a start to finish, fully working RAG application in about 50 lines of Python code and 20 lines of just a YAML file, which defines the vector database schema. I have no doubt that whatever RAG applications people are building will be substantially more complicated than this. I showed this to really drive home the point that anyone can start with these applications at a very simple level, get their feet wet, get their hands dirty, and be able to start building their own components, and then starting simply and building up from there. So this script here, and again, these will be available afterwards if you want to review, does the full RAG workflow. It imports documents, breaks them into chunks, loads into a vector database using Azure OpenAI text vectorizer and a Redis database to store the vectors in. Then it just goes through a simple loop to say, read in a user's prompt, check that vector database for semantic similarity with vector similarity search. And then if it finds anything, append that context to the new prompt. So now the prompt given to the LLM will be saying, here's my question, here's supporting information, please answer the question accordingly. And then it just retrieves the response to send back to the users. Please do try this out. Please do, get your hands dirty and build your own RAG applications. Understand, what bells and whistles are available, what tuning parameters you can play around with to start building and deploying your own components. That's RAG, but of course, being Redis, how can we not talk about semantic caching? We are known as a caching company, though of course we try to support all things software engineering. Once again, I want to show you how easy it is to be able to add semantic caching into your GenAI applications. Once again, starting as simply as possible. On the left here, we have the bare bones LLM client application. Just a simple loop that says, read in a user prompt, send it to an LLM, get the response and print it out. That is the simplest thing you can do. And I'm sure somewhere in your own AI application, you'll have some code that resembles something like this. So what now does it take to now add semantic caching with Redis VL into this component? That's what's on the right. So with an extra 9, maybe 10 lines of code, you can import a semantic cache, define a vectorizer that you want to use to be able to embed things. And then once again, go through the standard workflow, read in a user's prompt, and now just check to see if there's a semantically similar thing in your cache. If you do get a hit, return the hit and don't worry about calling the LLM. If you don't get a hit, just continue to call on the LLM. And then whenever you do get back, go ahead and store that prompt and response in your cache for future sessions. Um, that's it. It really is that simple. Now, once again, I'm sure as you build out your applications, you're going to want much more fine-tuned control. I promise you, we have all the tools, all the bells and whistles, and additional components for you to build out, production grade semantic caching. We showed the minimum here, but yes, we absolutely have control for cache updates and eviction policies, and fine-tuned control to make sure that the accessing of your cache is private and secure, to make sure that my data that I'm caching is not available to anyone else, and vice versa. All that is there, and they do exist. Please start simply. You can always build up afterwards. There are a lot of resources for getting started with RAG. I'd like to mention a few here. As we've shown already, the Redis RAG workbench is available on our GitHub under github.com/redis-developer/Redis RAG workbench. Feel free to clone and download that. All you need to get started is a Redis installation that can be running locally and for free, and an API key of your choice. In our demo, we used Azure OpenAI keys. Feel free to set up an account if you don't have one already and play around with their chat applications. Redis VL, which is the purpose-built vector database library, is also open source and available to try out. It makes working with vectors in Redis as easy as we possibly can, and it's purpose-built to support GenAI applications, so of course we can use it for many different ML and AI components as well. We also have Redis AI resources. So once again, under Redis developer GitHub/Redis AI resources, we have a whole host of example code, notebooks, scripts to show how you can do anything with GenAI, from simple chat applications to full RAG components to even non-GenAI applications such as search and recommendation systems. So once again, if you want to get your hands dirty and actually see what it is like to build out these applications using Redis and using vector search, these are some great resources for you to check out. And of course, Azure supports many things Redis as well. So there is the Azure Redis Intelligent Application Community Call. Feel free to look into that as well. And lastly, what I'd like to show is, being a machine learning practitioner myself, the majority of my work is Python, as was this demo. But I imagine that people are working in all different languages and environments. So Redis does officially support many different clients, all of which have access to the vector database components and vector similarity search. We're using Python, which is easily available. But we also officially support C#.NET, Node.js, Go, and Java. We actually have multiple different flavors of Java clients, Redis for synchronous components and Redis for asynchronous components. These are also officially supported and up to date. If one of these 5 languages still isn't your flavor, there are some excellent community libraries that we try to contribute to as well, written in C, PHP, Ruby, and Rust. So however you want to get started, we have tools available to you to help you get started. Looking ahead, what have we done in the world of Redis VL to better support GenAI? As I mentioned, it's a fast-moving field, AI and ML components. And so we've just recently released our latest version of Redis VL. In it, we have semantic chat session history. So once again, going back to the notion of how LLMs are stateless, how can we add chat history to each subsequent LLM call to be able to give it context of what it is you're talking about? The simple answer is just append the entire conversation. The smarter answer is similar to how we do, vector similarity retrieval. You can do semantic similarity retrieval over your full chat session history, giving it the relevant parts of the conversation that you've talked about so far to each subsequent call, not just the entire call. We've also recently released several new updates to semantic caching. We've shown here kind of the bare minimum in terms of what's available for semantic caching. I assure you there are many more tools in and around that area for you to be able to build out a purpose-built, highly performant cache that suits your exact needs. So I encourage you to check that out. And we didn't talk about it today, but we also have semantic routing. Semantic routing is an excellent tool where now you can actually direct user applications or user clients based on their semantic similarity calls. So if you're building out applications where you have several different large language models, perhaps large ones and medium-sized ones that do different purpose-built things, you can now route user prompts to the correct component of your choice based on semantic similarity, making sure that you're using the right application for the right prompt. Or you can even route it into a human in the loop if for some reason the prompt requires that they talk to a direct person instead of hitting an LLM. And all of this is powered by vector similarity. Those things are live and available today in Redis VL, so I do encourage you to check those things out. But of course, the field is still advancing and we're advancing with it. So what are some of the things that we're looking to build in the near future? We're building out components for LLM rate limiting. So as you build out your applications, traffic will increase, and some of these, token counts and network traffic can be quite large. We want to give you tools to make sure that you're rate limiting your applications to the best of your abilities and to the way in which you want to limit it to. There's a lot of work and a lot of buzz around the notion of large language model agents and being able to connect them with different applications such that they can do more than just return code or return text prompts, but they can actually execute and call out applications themselves. Expect big things from us to be able to work in that space. There's more news to come on that. And of course, cache analytics. Once again, now that caching is going from perhaps a pure backend software engineering component into a machine learning component, being a data scientist and analytics person myself, I really want to understand, and I'm sure everyone else does, how our cache is performing. What data is going in there, what types of data are going in there, what are the hit rates, what are the similarities between these things? How best can we understand what our cache is doing in GenAI applications? So look for more tools around there to be able to fully investigate what your cache is doing.
Yeah,
And I'll let
and
Catherine talk
just
about some of the new things in Azure.
yeah, just a few things on the Azure side. We're excited to have released a few new smaller SKUs. E1 is like 1 GB, E5, 5 GB of cache to start with. So if you are experimenting with your intelligent application, this would be great choices for quickly getting started and experiment with success. These are like faster in provisioning time and cheaper in cost. We are also having the latest Redis enterprise versions available in Azure. So I have not listed here, but you can try the latest Redis enterprise 7.2 in Azure that's available. And if you want anything like your custom upgrade and so on, you can feel free to contact our team. In addition, Microsoft provides this semantic kernel chatbot SDK framework. It's like an abstracted, simple way to build your intelligent applications. We recently released some new features like enhancing the enterprise requirement, improved memory connectors, and automation with agent. Basically, this is saying you can easily configure a planner and use the filters and plugins to customize, streamline your intelligent application task. For example, you can trigger an event on Teams upon some type of questions. So please feel free to check this out.
All right. I think that concludes the majority of our presentation. I believe there are probably several questions in the chat. I'm happy to answer some now if I'm able to. So perhaps, Becca, you can help us go through that and see if there are any questions that we're able to address right away.
Absolutely. There were quite a few questions. I took them all on a note on this doc. I will send over to you now, and we can start going through some of these. Oops. Let's scroll up here. So a couple questions from James Lang. When a Redis augmented query goes off to ChatGPT for processing, the augmented data is leaving the Azure environment and getting processed within OpenAI environment. Is that correct?
I think we are doing better than that. The Azure OpenAI basically is a service that hosts a copy of your model. So we make sure everything is getting processed within the Azure environment and the data is handled securely.
Awesome. We had a question around what top K stands for, the KNN number during the demo.
Oh, certainly. Yes. So when we do vector similarity search, you have the choice between how many similar vectors you want to return. There's always going to be a distance metric between your query vector and what's in the database. You can choose how many similar vectors you want to include. So the top K is just you want one piece of context or two or three or four or five. So if top K, I believe I had set to 3 as the kind of the same default. it grabbed the three most relevant pieces of context and appended that to the prompt.
Awesome. I think we had a couple questions about security as well. I'll go to Ivan's here. Does the data stay within the organization and is it not exposed externally?
I can answer that. So it depends on how you build your application. You absolutely can build things that are entirely within your own VPC or your own cloud system. So again, this demo, because it's a simple demo, I'm running on various different components. I have a local Redis instance running on my laptop. Though of course, you can so you can host a Redis application anywhere you want to. So if you want to run that entirely on your own servers or in your own cloud environment, you can host Redis there and the data will not leave. As Catherine mentioned earlier, if you're hosting everything within Azure, then it never leaves Azure.
Yeah, just a few points to add. So Azure is a very secure environment for hosting your applications. We provide the PaaS hosting services, the data services, and the large language model like GPT services, all hosted in Azure. And you can connect each services seamlessly without any password. Like we have a fully supported Entra ID component to enable service-to-service passwordless authentication. In addition to that, we provide secure networking options. So that makes sure your data is super secure in Azure.
Awesome. Are there data blob types that you would not suggest storing in Redis?
I would say no. I mean, in this example here, we've shown how to process PDF into text and then vectorize that so you can store the raw vector as well as the raw text. But we have support for many different data types. Basically, anything that you can serialize, so any JSON components, we have full support for images or audio files that can be serialized. It's really whatever you want. We actually have applications right now with customers where they want to do vector similarity search on images and video. We fully support that because at the end of the day, it's just a floating point list of numbers that we do similarity on. So as long as you can embed the data, we can do vector similarity search. And any other data type you can host directly in Redis and attach to a vector.
Perfect. I think this might be our last one. In RAG, if the base document is a PDF where the retrieved chunk comes from it is updated, how do you manage to find and delete the caches that are related?
Oh, that is an excellent choice. So once you do have everything in your cache, you're able to search your cache directly. So in this case, in the snippet of code we showed, you're searching the cache with a new user prompt. If you want to use any of the Redis AI tools, so whether that's Redis CLI directly to inspect the data, or we even have Redis Insight, which is another GUI application that allows you, actually, let's see if I can bring that up. Let me see if I can share my screen right now, and I'll show you exactly what this looks like. Can I share my full window? So hopefully everyone's now seeing my Redis Insight little terminal here. So once again, this is actually the data we were hosting in our application. And once again, just out of convenience, I was running this locally on this host port. But of course, this could be any Redis instance that you have anywhere, any cloud environment or on-prem resource. So what does the data actually look like inside this cache? Let's just take a look. Let's see what our keys are called. In this case, just based on how we called what document we had, the keys all prefixed with HAI 24 index report. So this is the name of the PDF file. And so these are the individual chunks that were stored from our PDF document. So you can go ahead and inspect what's in each individual one. So we have the embedding vector, which is serialized, so it's kind of nonsense, but it is just a byte string of numerical values. It gives you the page number where it's pulled from. It gives you the raw source. In this case, where did I store this PDF file on my computer? And what is the text that is actually stored in this? So this is the data that is being retrieved every time I do a vector similarity search. So again, it's kind of formatted funkily because it is coming from a PDF, but you do get the raw text file. So privacy and data governance, reliability, security, and transparency. So that's always in this specific hash example. So you can go through here, inspect and delete and remove individual things. So if I wanted to delete this one component, I can delete this one entry from the cache. Let's go ahead and do that. And of course, we have other tools as well to be able to inspect your cache and do this in a more programmatic way, so you don't have to do it manually.
Yeah, just a few things to add from the Azure perspective. We have a very well integration with other services such as Azure Functions tool. Azure Function is our serverless environment for performing tasks upon any triggering. So in the case of expired values or like the chunks where the sources got updated, it's possible to set up a pipeline like using the key space notification on a specific chunk value. And then if it's expired, you can then trigger the Azure function to go fetch the latest content and update it, or do it the other way. Like if you update your content, I don't know, in a database or like a storage store, for example, it can trigger the Azure function to go update another chunk of information and so on. So this is all very well supported, already available. You can look for the Azure functions, Redis binding and triggering tools.
Another tool that you can use is, and again, it wasn't shown in this demo for convenience, but we do fully support the automatic document expiry. So you can set a time to live of every single entry in the cache. In this case, it's actually shown here. I didn't. So right now it's set to no limit. This stuff will never expire. But again, it is just one additional parameter you can pass to every single cache call to say, hey, make this expire after 5 minutes or 5 days or any component or any time component you want to choose.
Thanks for walking us through that. That was really helpful. I think that was the last of our questions here. Oh, we've got one more. What's the similarity metric, cosine similarity in particular?
Yes. So cosine similarity, we'll have to bust out our trigonometry, is just basically the angle between two vectors. So the easiest way to think about this is if you picture a two-dimensional piece of paper, draw two lines that intersect at some point, you have an angle between them. And that is the cosine angle between those two things. So if that angle is 0, aka they're perfectly aligned like this, then that is a similarity metric. They are the same vector, they're a perfect match. If they're 90 degrees, then that's a worse similarity. If they're completely opposite, as in they're pointing in opposite directions, that's a similarity of -1. Basically, they're black and white. They're talking about completely different things. That's how it works in 2 dimensions. It's the same idea in 3 or 4 or 5 or 6 or 7 or 8 or 9 dimensions. Vector embeddings go into very high dimensional spaces. I believe this one is upwards of 1,500 dimensions in the embedding space. But the notion is exactly the same idea. You have two vectors that somehow align. There is some angle between them. And because they're normalized to all pass through kind of the origin point of 0, 0, 0, they always will intersect. It's just a question of, how similar, how different the angle is between them. And so that's the cosine similarity metric. And so it's always scaled between +1 being a perfect match, -1 being totally opposite.
Perfect. I don't know about anyone else, but that made me question how much math I've retained from back in the day. That was helpful though. Thanks, Justin. That was our last question that I see. But again, I've jotted everything down. So if there's any additional questions, or if you just want to revisit those questions, we can send a follow-up doc in the follow-up email after this event. We will also be sending out the recording of this session so that you can revisit it at any time. The QR code that you see on the screen there does take you to a brief survey. We would love to hear your feedback. Thank you to everyone who's already completed it. I did see one person who dropped a note in the survey response that they want to see more content like this, specifically around AI, and I'm excited to share that we will be producing more content like this. We have a plan to produce more webinar programs around AI, as well as other content that we'll be pushing out over the next couple of quarters here. So we'll definitely keep you in the loop when all of that content's coming out. Keep an eye out for notes from Redis for all of those invites. And thank you again for joining and spending all this time with us. And thank you to Justin and Catherine for taking time out of your morning as well to walk us through all of this great content.
Thank you.
Thank you, everyone. Hope you enjoyed it.